Hello, my name's Tom Hartley. I'd like to tell you about a plugin I've been working on. It's a spatial convolutional reverb called TheVerb. TheVerb works by simulating the sound that you'd hear if your source was placed at a specific location in a given spatial environment. And you can then move your source to different locations within that soundstage. Probably the easiest way to explain how it works is for me to show you the interface, take you through some of the controls, and demonstrate some of the effects that you can achieve. So that's what I'm going to do now. This is my project already set up, and I will temporarily add it to the channel where you can hear my voice coming. The most important control is the XY pad here that allows us to move a sound source around our soundstage. So here is the sound source. Our listener is right in front of the soundstage, just here where my mouse is. And as I drag the puck around, you should be able to hear the sound source moving. So you can hear my voice moving now from left to right, just over here. So that's the main control, and really that shows you everything about the plugin, what it's for. It's for simulating a sound source, placing it in a specific location in a particular environment. Now the way we do that is with two components. There's the direct sound that we're getting straight from the sound source to our ears, and we hear that when we turn this mix right down to 0. Now you're just hearing the direct sound from that sound source to the listener, and as we move it around you can hear the direction and distance indicated. So if I move it further away, it's probably going to get quieter, and as I move it nearer it gets a bit louder, and as I move it to the left you can hear the sound moving to the left and here over to the right. So that's the direct signal, just the sound coming from that sound source and going straight to the listener's ears. And if I turn this knob, this mix up to 100%, now we're going to hear the room sound. So now we're not hearing the direct sound at all. All we're hearing is the reverberation as that sound from the sound source is radiating in all directions, and it's hitting the walls, floor and ceiling of the room, bouncing around, not coming directly to our listener, and then after it bounces around a certain amount, some of the sound is being absorbed and then some of it is eventually coming back to our listener. So a mix of those two things gives us an impression both of where the sound is and of the space that we're in. And the idea is that that's very useful to provide a sense of realism when we're putting sounds into a mix. So I'll just go into a little bit more detail about what you can see here on the screen. So in the top right here you can see an indication of the room sound. So this is how the sound gradually fades away after it's made. It takes a few seconds for those sound waves to bounce around, hit all the walls, get absorbed by some of the walls, reflected by some of the walls, and those sounds then come back to our listener eventually. But most of the sound we get is from the first few reflections, some of the sounds being absorbed, and the colour here is indicating that the higher frequencies are being absorbed a bit more than the lower frequencies, so it goes a bit redder. And after about 250 milliseconds, maybe 500 milliseconds, most of that sound has decayed away. And what you can see on the bottom part is the indication of what we're hearing right now. Okay, so if I make a loud sound, you can see even up to 300, 400 milliseconds later, we're still hearing a little bit of the sound of my voice. Most of what we're hearing at a given moment has come just from the first few reflections, but some of the later reflections are still reverberating, and that's why the sound is extended in time. So that's what this upper plot shows. You can see it's graded in 250 milliseconds there, and also because we're running it from within a door, we can see these beats per minute markers that give us an indication of where the beats would fall, 1/8 and 1/4 of a beat. Okay, so the next thing to look at is the top left hand corner, and this really shows us how the direct sound is working. So I'll turn the mix to 0, so you're just hearing the direct sound now. As we move the sound source around, when it gets further away, the signal takes longer after the initial signal is emitted from the sound source for the listener to hear. Okay, so the further away it gets, it takes longer to return to the listener's ears, and also it gets a bit quieter because a smaller proportion of that radiated energy is hitting their ears. More of it's being hitting the walls and the floor, but relatively little is coming straight to the listener. And as I move it forward, that delay gets shorter. So the time scale here, that's 25 milliseconds. If I move it right back to the edge of the sound stage, still only 12 or 13 milliseconds right to the front, practically just a few meters away, so there's barely any delay. Now as I move the sound source to the left or to the right, like this, then the delays affecting the left and right ear are going to be slightly different. So here you can see that there's less of a delay for the left ear than for the right ear. The sound's getting to my left ear quicker than my right ear, and that's why it sounds as if it's on the left-hand side. The left ear represented by the blue part of the bar, and the right ear being represented by the orange part of the bar. And if I move it onto the other side, you'll see those two switch around, and now we're hearing the signal from the right-hand side slightly quicker in our right ear than our left ear. Okay, so now we get similar kind of subtle effects on the actual reverb itself. If we listen to the room sound, we can turn that up. So now we're hearing 100% room sound. And what you notice is the sound from the left-hand side of the room, the reverb is slightly different than from the middle. And again, from the left-hand side of the room, slightly different. If we take it further away, then we get a different sound still. So normally I would have this mix level set to quite a low value when I'm using it in my own projects. And that's because I really like to use this type of reverb as a subtle way of putting different elements into the same space at the same time. That's its main use case. Okay, so I hope that gives you a useful overview of the plugin, what it does and how to operate it. If you'd like to find out more, you can join our beta program by signing up at hartleydsp.com, and then you'll be able to download a copy of the latest version to try it yourself. If you want to find out more, stick around, look out for new videos because I've got plenty more demos on my site, and I'll also be along to explain a little bit more about how to use the plugin in future videos. But until then, goodbye and thanks for watching.